Okay, welcome back to the class, my dear students. So, in the previous class, we were speaking about the resistance, correct? We said resistance, it is not depending upon the potential difference or the current. It depends upon the material, which material you have taken, and it depends upon the dimension of the material, and also it depends upon what? Temperature. One more thing I want to speak about here is resistance. It is nothing but opposition for the flow of charges. Okay. If resistance is higher, then the flow of current is less. The current produced is less. If the resistance is more, what I was speaking, I'm sorry, if R is high, that is resistance is very, very high, less amount of current flows. If R is low, then more amount of current flows. Now, look here. Since it depends upon the material and dimension, resistance is proportional to the length and inversely proportional to area. Just like a water pipe. We will consider one water pipe. Its length is very, very small. Now, water should flow from one region to another region. Okay, water is moving from one region of the pipe to, let me consider this as a pipe. Okay, water should move from one region to another region. If the length is more, whether more amount of water reaches here or less amount of water reaches here, you can make, as the length increases, the reaching of current will be here very, very late. Correct? I mean, water is very late. In the same way, as the length increases, resistance increases. Opposition, as the length increases, opposition for the flow of current also increases. If the length is very small, then the current can easily reach here. Correct? So, as the length decreases, resistance decreases. It is directly proportional. If the area of cross section is more, if the pipe is having large area of cross section, then as the area of cross section increases, amount of current flowing is also increases. But here you see here, resistance is inversely proportional to area of cross section. That means as the area increases, resistance should decrease. That means more amount of current flows. As the area increases, more amount of current flows. Resistance is less. If the area is very, very small area is there in that, what example we have taken, that is pipe, then less amount of the water will flow. That means resistance is more. Same way here also, as the area of cross section increases, resistance is less, therefore current flow is more. Once I'll write, resistance is nothing but opposition for the flow of current. So, as the current increases, resistance decreases. As resistance increases, current will decrease. This you should not forget. Understood? So, now, as the length increases, resistance will increase. Therefore, as the resistance increases, current will decrease. As the area of cross section increases, resistance will decrease, and therefore current will increase. This relation you should know. So, to remove this proportional, a proportional constant, and put equal symbol, a proportional constant rho is given. The rho is nothing but a proportional constant called resistivity. Rho is nothing but a proportional constant called resistivity. So, what is resistivity? Resistivity is nothing but a proportional constant. So resistivity depends upon the material of the conductor and the temperature, but not on the dimension. Resistivity is depending upon the temperature, and also it depends upon the material, but it does not depend upon the dimension of the conductor. Okay. What is the unit of resistivity then? What is the unit of resistivity? See here, rho is equal to RA by L. Ohm meter square by meter. Ohm meter is a unit of resistivity. Ohm meter is a unit of resistivity. Now I will give you one homework. For all this, that is current, then resistance, then for resistivity, you have to write the dimensional formula on your own and you have to send as a homework. Okay? You have to send a homework that is, you have to write the dimensional formula for resistivity, resistance, current. Okay? I have given you the SI unit. You have to write the dimensional formula. You have already learned how to write the dimensional formula in your first year. So I think it is easy for you to write the dimensional formula for all these. Correct? Okay, R is equal to rho L by A. Rho is nothing but RA by L. Now, in the place of R, if you substitute as rho L by A, then the formula is V is equal to I rho L by A. One more thing you should remember, current density, concept of current density. Do you know what is current density? You know what is mass density. Mass density is nothing but mass per unit volume. Do you know what is current density? Current density is nothing but current per unit area taking normal, along the normal to the flow of charges. That means it is nothing but current per unit area taken normal to the direction of the current. You will be speaking normal to the direction of current. How the current flows in the same direction we will be speaking about normally. So what is the definition? One mark question. What do you mean by current density? Current density is nothing but current per unit area taken normal to the direction of, normal to the flow of current. So J is equal to I by A. This current density is nothing but a vector quantity. So one more work for you. You have to write the definition of resistance. You have to write the definition of resistivity. You have to write the definition of current density. What is the unit of current density? Ampere per meter square. For this also, please write the dimensional formula. Okay, current density. Next, now the next concept which we are moving for is by using the concept of the second chapter. You know the relationship between electric field and the potential. What is the relation? E is equal to delta V by delta L, correct? So if there is a conductor of length L, okay, then I can say E is equal to V by L, correct? Or else I can write V is equal to E into L. Now the next one derivation is there, so you don't forget this. One derivation you had, remember, in the second chapter. From this one to this one there is a distance, that 5 marks derivation. Using that, you know this formula, right? Okay. Now I want to derive one derivation, that is derive the expression for the resistivity or conductance or conductivity of the formula. Conductivity. How to derive? expression for conductivity. See here. Let us consider a conductor of length L. Consider a conductor of length L. Let V be the potential difference maintained across the ends of the conductor. I be the current through the conductor. And R be the resistance. According to Ohm's law, I can say V is equal to IR. Correct? We know that R is equal to rho L by A, where A is the area of cross section of the conductor. Okay, and rho is the resistivity of the conductor. Then I can write V is equal to I rho L by A. We also know that I by A is nothing but J rho L. Correct? Since J is equal to I by A. We also know that when the electric field E is there, electric field E is equal to V by L. Since length is L and potential difference is V, I can write E is equal to V by L, and also V is equal to, this implies V is equal to E into L. Correct? We know that. Then, now I can write in the place of V as E into L is equal to J rho L. Correct? L gets cancelled. So, E is equal to J into rho. Or rho is equal, this is a relation between the electric field and resistivity. Okay? Or else I can also write E is equal to, rho is equal to E by J. Where rho is nothing but resistivity of the material. Or else I can also say conductivity is nothing but a reciprocal of resistivity. That is, rho is nothing but reciprocal of conductivity. Rho is nothing but resistivity. Sigma is nothing but conductivity. Okay. So, resistivity means opposition offered. Conductivity is nothing but opposite of resistivity. So, I can say resistivity is reciprocal of conductivity. Since resistivity is reciprocal of resistivity, I can write 1 by sigma is equal to E by J, or sigma is equal to J by E, or else I can write sigma into E is equal to J. One more relation. This is the relationship between resistivity and electric field. This is the relationship between electric field and conductivity. So, this derivation is very, very, very important. They can be asked for how many marks? 5 marks. And also, this is nothing but J is equal to sigma into E. This is an equivalent formula for Ohm's law. This is equivalent formula of Ohm's law. This is equivalent form of Ohm's law. How it is equivalent form? Can you help me? Shall I give it as a homework? You have to say how it is equivalent to Ohm's law. Substitute. J is nothing but I by A. sigma E, everything you substitute, it will come, you will get back to the Ohm's law formula. So, it is a nothing but equivalent of Ohm's law. Which formula is equivalent of Ohm's law? This is J is equal to sigma into E. What is sigma? Sigma is nothing but conductivity. It is nothing but reciprocal of resistivity. Understood? So what we have done? Derive the expression for conductivity of the material. So heading of this one is derive the expression for conductivity of the material. Or else they can also write derive the relationship between conductivity and current density. Current density and conductivity and electric field. Anything can be asked. Okay. So expression for the conductivity of the material. What we have to do? Let us consider a conductor of length L and area of cross section A. Let V be the potential difference maintained across the ends of the conductor. R be the resistance and I be the current I be the current. According to Ohm's law, V is equal to IR. We know that R is equal to rho L by A, where rho is resistivity of the material. Then substitute in above. Substitute 1 in star. I'll put this as star. We get V is equal to I rho L by A. Since J is equal to I by A, that is current density, we can write V is equal to J rho L. We know that E is equal to V by L. Therefore, we can write V is equal to E into L, where E is nothing but electric field. Substitute this. Substitute 3 in 2. So what do we get when we substitute 3 in 2? E into L is equal to J rho L. L gets cancelled. E is equal to J rho. Or else rho is equal to E by J. Correct? Then we know that conductivity is nothing but reciprocal of resistivity. So I can write resistivity is equal to 1 by conductivity. So substitute in the place of rho. We get this one. Therefore J is equal to sigma E. J is equal to sigma E. This is nothing but the expression for the conductivity of the material. And this expression J is equal to sigma E is the equivalent form of Ohm's law. Equivalent form of Ohm's law. Understood? Very, very, very important. Very, very, very important. If any doubts, you can ask. Okay? Next. The next concept what I want to move for is about the drift velocity. Do you know what is drift velocity? What do you mean by drift velocity? There are few 1 mark questions, many 1 mark questions from this chapter. See, for example, nearly 9 to 10 marks question will come from this chapter. Very, very important chapter this is. Nearly 10 marks question will come from this chapter. We said metals are having large number of free electrons in it. Correct? These free electrons, when they are drifted, it is having some velocity. So drift velocity is nothing but average velocity with which the free electrons get drifted. Average velocity with which free electrons are drifted towards the positive end of the conductor. You write positive as Positive, positive spelling, okay? Don't write like me. Towards the positive end of the conductor. Under the influence of external electric field. Influence of external electric field. See, I said the free electrons will be moving, correct? But to make it to move in one particular direction, we have to give a potential difference. When the potential difference is given, the electrons are drifted and made to move in one particular direction. Drifted means just the meaning of the drift is hold it and make it move. That is nothing but meaning of drift here. But you should not write that hold it and move. What you have to say is drift velocity is nothing but average velocity of the electrons with which the electrons are drifted to move towards the positive end of the conductor under the influence of the external electric field. So, average velocity with which the free electrons are drifted towards the positive end of the conductor under the influence of external electric field. Now a small work for you to derive the expression for the drift velocity. Before finding the expression for the drift velocity, what the work you have is, you have to write one more definition, that is about mobility. What do you mean by mobility? You know mobile. What is mobility? Is there any relation between mobile and mobility? Cell phone? Is there any relation? Mobility is defined as the magnitude of the drift velocity per unit electric field. Magnitude of the drift velocity per unit electric field. Mobility is given by mu and drift velocity is given by Vd. It is nothing but, what is mobility? Mobility is nothing but defined as magnitude of the drift velocity per unit electric field. Magnitude of the drift velocity per unit electric field. Then now your work is to find the expression, derive the expression for drift velocity. The next work is derive the expression for drift velocity.